Step-by-step exam solutions. Okay, physics class, training you to excel. Subscribe to step-by-step exam solution. Like this video. Share the link of this video with others. Click for alert so that you receive the next video. Please drop your comment for a better service. Okay, physics class, present 5 steps to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, you perform. These are 5 steps to exam success. Okay, physics class, present step-by-step exam solution to equilibrium and equilibrant of forces. In this video, we'll be studying number 1, fundamental concepts of force, resultant, and equilibrant. Number 2, conditions of equilibrium of concurrent forces. Number 3, we'll be looking at the Lami's theorem and method for finding equilibrant of forces. Our objective for the presentation are: number 1, explain the concept of a force, a resultant of a force, and equilibrant of a force. Number 2, state the conditions for a system of concurrent forces to be in equilibrium. Number 3, use Lami's theorem to find the equilibrant of 3 forces. We move to the next slide for the discussion proper. Number 1, what is a force? A force is a pull or push acting upon an object, a body, a particle. And a force is characterized by: number 1, magnitude. Number 2, direction. Number 3, point of application or where the force is applied. Number 1, magnitude. Number 2, direction are very important because they define a vector quantity, meaning that a force or forces or force is a vector quantity. Resultant force. Resultant force is a single force that represents the vector sum of 2 or more forces acting on a body. If you have 2 forces acting on a body, or 3 forces, or 4 or 5, one force that can replace those forces acting on that body is referred to as the resultant force. The good news is that the resultant force produces the same effect as all the individual forces acting together. It produces the same effect as the forces it replaces. So that gives us resultant force. Number 3, equilibrium. Equilibrium is a state in which the net force acting on the body is 0. What do you mean by net force? By net force, we mean resultant force. The total force acting on the body. The total force acting on the body is what we refer to as net force or the resultant force. And when that total forces or the total or resultant force is 0, we say that the system is in equilibrium. According to Newton's first law of motion, a body will either remain in a state or remain at a state at rest or continue to move with constant velocity in a straight line. Now, when the body is at rest, we refer to that as static equilibrium. And when the body is moving in a straight line with constant velocity, we refer to that as dynamic equilibrium. Whether static equilibrium or dynamic equilibrium, there is no acceleration. Absence of acceleration simply means the system is in equilibrium. So mathematically, the condition for equilibrium would be that the sum of all the forces acting along the x-axis will be 0, and the sum of all the forces acting along the y-axis will also be 0. Look at it here. The sum of horizontal forces 0, the sum of the vertical forces will also be 0. Now, moving to the next slide, we'll define equilibrant. Equilibrant is a force. Equilibrant is a single force that exactly balances one or more forces acting on a body, placing the body in equilibrium, making the system to be in equilibrium, making the particle to be in equilibrium. If equilibrant balances the resultant to keep the system in equilibrium, it then means that equilibrant is equal in magnitude to the resultant, but act in the opposite direction. Equilibrant and resultant are equal. They only act in the opposite direction. So if I have three forces, F1 and F2 and F3, acting on a body, and so that the resultant is R, it means that the system will be in equilibrium. If I add the equilibrant to the resultant, I will get 0. Why? The equilibrant is the negative of resultant. So if I add negative to a positive, the result will be 0. So therefore, to find the final condition for equilibrium, the sum of the equilibrant and the resultant must be equal to 0. Now that brings us to the conditions for equilibrium of a particle, conditions for equilibrium of a body. When many forces act on a body, act on a particle at a common point, at a single point, the conditions for equilibrium are: number 1, the vector sum of all the forces must be 0. We have said that already. The vector sum of all the forces must be 0. The vector sum of all the forces must be 0. Number 2, the polygon of forces closes. What do you mean by the polygon of forces closes? If I draw the forces using an arrow, so that the tail of an arrow ends with the head of the other one, and you go round either in a clockwise or anti-clockwise. Now, the final vector force diagram we are going to get will close. And when that closes, we say it forms a closed polygon. It forms a closed polygon. I will illustrate that in the next slide for proper understanding. For a system to be in equilibrium, the forces must be concurrent. What do you mean by the forces must be concurrent? The forces must be acting at a point. And not only being concurrent, the forces must also be coplanar. Being coplanar means all the forces act on the same plane. So these two conditions are very important for a system to be in equilibrium. Now, to the next slide to illustrate the condition of equilibrium using diagram. Now, here I have a force, the green arrow. Now, the orange arrow is the equilibrant. The equilibrant, the tail of the equilibrant starts from the head of the force, and the head of the equilibrant ends at the tail of that force, meaning that the equilibrant now is in the opposite direction to the force and is exactly equal to the force in magnitude. Therefore, F minus E will be 0. The summation of F, the resultant force, the total force must be 0. For two forces, the blue arrow and the green arrow, now they flow in order like that. The black arrow is the resultant of the blue and the green. Now the equilibrant must be equal in magnitude to the black arrow, the resultant, but must act in the opposite direction. So therefore, if I add the blue and the red and the green, and I subtract the equilibrant, which is equal to the resultant, but act in the opposite direction, the resultant force will be 0. For more than two forces, we have the blue force, we have the green force, and then we have the purple and then the orange. The black is the resultant force. The red is the equilibrium force. The equilibrant is equal to the black in magnitude, but act in the opposite direction. So that if I add all the four forces, 1, 2, 3, 4, giving us this, the resultant force, the black, and then I add that to the equilibrant acting in the opposite direction to the resultant, I also arrive at the resultant force is 0. That means the equilibrant is a single force that balances these four forces to keep this system in equilibrium. We now move to the next slide for the continuation of our discussion. Now, we're talking about Lami's theorem. Lami's theorem is used to solve equilibrium problems that involve three concurrent coplanar forces. That gives us the three conditions to apply Lami's theorem. There must be three forces. That's the first one. The first one, there must be three forces. There must be three forces. Number two, all forces must be concurrent. As explained already, their lines of action must meet at a single point. Not only that, they also must be coplanar, meaning that they must act on the same plane. The system must be in equilibrium. The forces balances each other out. So now, having explained this, we now come to the statement of Lami's theorem. If three concurrent forces acting on a body are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. That is the Lami's theorem. In theory like this, you may not find it easy to understand. Let's illustrate that with a good sketch. I have the three forces. Now let's start with the black force, F1. This F1 is the resultant of F3 and F2 and is directly opposite the angle alpha. According to Lami's theorem, this force F1 is proportional to the sine of this angle. Following the same argument, the force F2 will be proportional to the sine of angle beta. The force F3 will be proportional to the sine of angle gamma. Now, mathematical formulation. For three forces F1, F2, and F3, if they are in equilibrium, as we have seen in the diagram above, from our mathematics, the sine rule, we can see that F1 over sine alpha will be equal to F2 over sine beta is equal to F3 over sine beta. Remember what we said before. F1 is proportional to sine alpha. F2 is proportional to sine beta. F3 is proportional to sine gamma. I'm making all that ratio equal to each other. Alpha is the angle between F2 and F3. Beta is the angle between F1 and F3. And then the gamma is the angle between F1 and F2. Already we have explained all these things. You can see them represented in this diagram. For emphasis, let's illustrate that again. F2 is proportional to the sine of beta. You can see it here. Then on the other side, F3 is proportional to the sine of gamma. You can see it here. And finally, F1 is proportional to the sine of alpha. You can see it here. So that gives us the Lami's theorem mathematically represented. Now we're going to move to the next slide to solve problems. Now, example 1, and the only example we solve. Two forces of 50 newtons and 100 newtons are acting at a point on a body, and the angle between them is 120 degrees. Given that the angle between the 100 newton force and the equilibrant force is 150 degrees, find the magnitude and direction of the equilibrant force in relation to the 50 newton force. Now we have seen this. We want to solve this question together now. So number 1, let's make a sketch of the diagram. That's 50 newton force. That's 100 newton force. The angle between them is 120. Now the third force, E, and the angle between the third force and the 50 newton force is beta. And then the angle between the equilibrant and the 100 newton force is 150 degrees. Having drawn this, we go to step number 2, the formula, the Lami's theorem. And in the Lami's theorem already we know that F1 over sine alpha is equal to F2 over sine beta is equal to F3 over sine gamma. And then we are going to make direct substitution into that formula. 50 over sine 150 is equal to 100 over sine beta is equal to the equilibrant unknown over sine 120. And in solving the equation with a formula like this, having 3 terms, we cannot apply any 2 with 2 unknown. So we are going to look at any 2 with 1 unknown. 50 over sin 150, all known. E over sin 120, the equilibrium force is the only unknown. So we can use the first one and the third one to find the equilibrium. Applying that now, we have sin 150 over 150 is equal to E over sin 120. And then we make that's the subject, that gives us the same thing here, and then we make E the subject of the formula. So E will give me sin 50 sin 120 over sin 150. Remember, 50 sin 120 is obtained by cross multiplying 50 sin 120. And then you cross multiply this, you have E sin 150. Dividing both sides by sin 150, then E is now left standing alone. Then you are going to have sin 50 sin 120 over sin 150. Then we are going to substitute. E will be equal to 50 times 0.866 because sin 120 is 0.866 and sin 150 is 0.5. Now putting those values there and using calculator, we are going to have the equilibrium force is equal to 86.6 Newton. Then we are going to use the other two to find beta. And to do that, we'll look at the first one, the numerator and denominator both known. And here the only unknown is the sin beta, which is the denominator. So we can make use of those two. So 50 over sin 150 is equal to 100 over sin beta. Then we make sin beta the subject by cross multiplying. Then we are going to have sin beta being the subject will give us 100 sin 150 over sin beta over 50. Then we are going to make direct substitution. 100 sin 150 is 0.5 divided by 50, and that will give me sin beta is equal to 1.000. Then arc sin beta will be equal to 90 degrees. That means beta, the angle is equal to 90 degrees. Now we have solved this problem. Remember to subscribe, like the video, share the link of this video with others, click for alert so that you receive the next presentation. Thank you for watching.